In this video I'm going to be looking at the solution to question 3 from the January 2010 Edexcel D1 paper. The topic of the question is Dijkstra's algorithm and route inspection. The question refers to a network given in figure 3 where the numbers of each arc are times to travel along each of the paths. We're asked in the first part of the question to use Dijkstra's algorithm to find the quickest route from A to H and stating the quickest route and the time taken. In the second part of the question it says that Kevin must walk along each path at least once and return to his starting point. So we're asked to use an appropriate algorithm to find Kevin's quickest possible route starting and finishing at A. And you should make your method and working clear in that part of the question. So looking first of all at the Dijkstra's algorithm problem, this is one where we start off with labeling the first vertex, and it's the first one to be labeled, so it's given a number 1 and the distance that we are from the start point is marked as 0. So what we're doing here is, if we just look at the key for a second, the order of labeling and what's going to be the final value. Now the working values come in for the other points because we don't know initially whether these are going to be the shortest distances or not when we first put them onto the diagram. Now I suppose initially we should have put in a working value there also of 0, however it won't matter if that one's missed out. So Dijkstra's algorithm says look at all of the other points, and that's all of the points that can be reached from the vertex which has just been labelled. In other words, which points can we reach from A? And those are B, C and D. And we write in there the length of the route from A to each of those. So to B it's 15, to D 20 and to C 19. You then look at all of the vertices that have not got a permanent label. That, at the moment, of course, that is the 3 that we've just labelled. So we look at those and choose the smallest. That one is B, with a value then of 15. So that goes in the final value box, and this was the second point to be labelled. From that point we look at those that can be reached from B, so that's D and E, and update the working labels in those points. Now for E then it's total of 8 plus 15 is 23, and for D it's 15 plus 14, which is 29. Well, 29 is larger than the 20, so there's no point updating that. 20 is still the shortest. We then look at all of the points which have not got a permanent label. Now remember that you must come back and look at all of these. So you must come back to C as well. And in fact it's C which has got the smallest label of 19 at the moment. So that becomes the third point to be labelled, and it has a value of 19. So repeating this process then, going forward from C to F, 19 plus 10 gives us a value there of 29, and from C to D 19 plus 12 is 31, so again that is larger than the current value of 20. Look at all the points D, E and F that have not got permanent labels, and we get to see that D is the next one to be labelled, and it has a value of 20. Starting that point D and working to the other points from D to E is 2, so that's going to now change. 22 is smaller than 23, so that we change that to 22. Now if you are doing this, make sure that the number underneath your crossing out can be read. So that 23 is important. It's not the final value of course, but it needs to be read. From D to G is 6, so that gives us a working value of G of 26, and from D to F is 7, that gives us a value of 27, which is less than the 29, so it becomes the new working value. The smallest one there is E, so E becomes the 5th point with 22. Forward from there, from E to H is 15, so that gives us a value of 37. From E to G is 3, giving us a total of 25, so that one is updated to 25. Looking around there, we've got a smallest value of 25. Remember, you're looking at all of these points, so this is the 6th point to be labelled, and it's a value of 25. Going forward from that, 25 plus 11 to give H is 36. From G to F is 4, so that would be 29. So that one's not going to, F is not going to change from its 27. And that is now the smallest one to have not yet been given its permanent labelling. So that's number 7, value of 27. And then we go forward from there. 27 plus 21, clearly bigger than the 36. So the label at the end, the 36 at the end, is the smallest value for H, and that becomes the final point, 8, to be labelled with its value 36. To calculate the quickest route, we work backwards along here, starting with the 36, and look at the path where 36 minus the weight of the path is equal to the number at the other end of that arc. So for example, if we take the 15 there, 36 minus 15 is 21, and that's not equal to the 22 which we have in E, so that's not part of the path. However, if you look at the G to H, we've got 36 minus 11 is 25. So G to H is on our shortest path. Now I can indicate it with just a squiggly line. And continuing that way, the path then goes from G back to E, because 25 minus 3 is 22. Then from E to D, and finally from D back to A. So the quickest route is A, D, E, G, H, and its length, or the time taken, is 36 minutes. The marking for that part of the question, there was a method mark for basically getting the right idea. So where there have been some updates and the method is clearly being applied correctly, then a method mark was given for that. There was then the diagram sort of split into two. So to the left of that line, if that was correct, was an A mark, and also if to the right of that line is correct, there was another A mark. Then an A mark for getting the quickest route, and A1 follow through. So had you made a mistake in the numbers, you would get the mark for writing down the time taken. So a total there of 5 marks. The second part of the question is about route inspection or Chinese postman problem, and the way to do this is to look first of all at the odd nodes. So we identify the odd nodes, which are A, B, C and H. So the odd nodes A, B, C and H. These can be paired in 3 different ways: A, B with C, H, A, C with B, H, and A, H with B, C. Now it's probably worth saying that we need to look at the actual smallest route, for this, and the route from C to H is obviously not direct. So looking at that one first, from C to H, the smallest route is C, F, G, H, and that has a value of 25. A to B is a value of 15, and in total then that gives us 40. Doing a similar thing for AC and BH, the values are 19 and 24, which is 41, and for AH 36 and 22, which is 58. The AH being 36, that was the answer to part A. So do use part A if it becomes apparent that it's necessary. You don't need to search through this. We know that AH is 36. However, okay, we've now identified the extra paths that would need to be taken, and the smallest of those is at the top. So we would have to have AB and also to repeat CF, FG and GH. The question actually doesn't ask us to do any of that to find an actual route. It simply says find the time of Kevin's quickest possible route starting and finishing at A. So once we've done that, the time of the quickest route will be the 167, which is mentioned in the diagram. So it's 167, that's the total weight of the diagram itself, plus the 40 that is our smallest pairings. So we get there a total of 207 minutes. The marking for this part of the question, a method mark for identifying the odd nodes, and then A marks for each of these pairings, followed by an A mark for the answer 207. So a total there of 5 marks. Well, that's the end of the solution to this question. You can find solutions to other questions at www.furthermaths.org.uk.